So, there's roughly 1 billion different ways to start this off. I have a nifty little animation I want to show you that I found. I didn't make it. Can't take credit. I could have, but it's too late. I already said I didn't. But the basic idea of trigonometry. And so anybody, now some of you guys might be retaking this class, but has anybody ever heard of trigonometry before? Trig stuff? And do you guys, so if you've never heard of it, it's if you have an oscilloscope, or if you look in the background of some movie where there's scientists doing their thing, you might sometimes see the oscilloscope with the curvy line. So that's what's known as a sine wave. So we're going to get into that kind of thing where we have these functions. We're going to define new functions, which means we're also going to have to do what?
Define their inverse.
And define their inverse so that we eventually can solve equations with them in it. Right? If I know how to add, I better know how to subtract also, so I can solve equations with addition in it. So here's the true basics of this. We start with this guy, section 5. And the reason I bounce between chapter 5 and chapter 6, so again, this is a good example. He doesn't do so well, in my opinion, with pre-calc. Chapter 5, you approach this with one unit of measurement. And chapter 6, they redo a lot of the same stuff with another unit of measurement. So it's like learning something with inches and then trying to relearn it with centimeters. Why relearn it? Just know how to convert between the two and everything's the same. Are you guys semi with me? You wouldn't say, here, now you've got to turn the ruler around. That's a whole other chapter. No, screw that. It's the same. You still measure things the same way. Right? So we all know how to measure angles, maybe. What do we use to measure angles?
Degrees.
Degrees. All right, so that's the units that we know, and that's actually a unit that was completely made up by humans. Thus. So we took a circle and we cut it into 360 pieces. And why do you think we did that?
Because the circle is 360 degrees?
No, it's that because we said it was. Period. It's not given. It isn't something that you look at a circle and you go, well, it's 360 degrees. No, that was completely made up by us. We could have made it 411 degrees. Why would we make it 411 degrees?
It's nice round.
Yeah. What do you want to do with a circle normally?
Break it up.
When I see circle, I normally think of pi, and you can have all kinds of stupid trigonometric jokes about that, but you want to cut the freaking pie up. And I want to know how big the slice of pie is and all kinds of stuff. So we measure, so that's why we gave it 360 degrees, because 360 can be broken up in a lot of freaking ways. 360 has a lot of factors. But I really want you to understand this. It's completely made up. We could have broken up a circle into who knows how many little parts. It didn't have to be 360. Another reason we did it is because how many seconds in a minute? 60. How many minutes in an hour? 60. So this 60 number, we could have made it 3,600 degrees, and in my opinion, that might have been better. But that 60 number is really important for us, right? And I won't get into the whole Babylonians and all kind of stuff. We'll just leave it there. Babylonians actually had a number system. You know how our number system is based on 10? They had a number system based on 60. So I'll let you guys decide how much interested you are in that.
Are we doing mills too?
What's that?
Because I know it's degrees and mills.
Mills?
Yeah. 6,400 mils in a circle.
Oh.
1,300 degree mils per.
We're going to deal with degrees and something called radians. Right. So chapter 5 is really all about radians, and chapter 6 is all about degrees. So that's why I like to bounce between them, because when they introduce one idea, I want to look at it both from radians and degrees at the same time. So if you look at your homework, I'm bouncing between chapter 5 and 6 a lot. And that's why. They're dealing with the same idea, just from a different unit. So here we have what's called a unit circle. Anybody have any idea why it's called that?
The radius is 1.
Beautiful. So that word unit is really reserved for the number 1. Let's see how good of a circle can be. Well, for me, that's really good. It's got some cheeks, but I can deal with that. So if it's got a radius of 1, that's a unit circle. Now, what's the formula for the circle? What's the formula for the circle? We should know this. Good. x squared plus y squared equals 1. And I really want you guys to understand why that is. Why is that? I mean, I don't know if you remember, I think I talked about this with you guys, why that's the formula for circles. But why would that be? So here's a point. Here's some point xy. Right? Here's some point xy. So x is, for that point, is right there. And y for that point is right there. And if I connect these things, I've got a right triangle. Cool. So as we get into this, trigonometry truly is the study of ratios of sides of right triangles. That's all it is. We start with the circle, a unit circle, because it's a really nice visual for what's really going on, and it gives us a chance to get into this before we really talk about triangles. But really comes down to this has really got a lot of triangles in it. It's the last thing you'd think a circle has in it. But you can imagine any point that I can draw its representative right triangle. You guys kind of, it's making it look like you've just seen something, a monster. Yeah.
So you said the normal unit is 1, right? So 1.5.
Yeah, this would be 1.
That would be also 1, okay.
So what's got to be true about this point? Yeah, it's got to work in that equation, right? So if I go to, if I said, let's say this x looks to be about 0.5, right? About halfway. What would y have to be? Don't say 0.5 because there's squares in there. How do you figure out what y is?
Square root.
Yeah, you plug it in, right? So do that thing I just said. I thought you guys were just staring at me. Somebody trying to do in their head, or what's happening? They're waiting. Just continue writing stuff down, Jeff.
Stop asking.
Don't ask me to think. So you plug in there, 0.5 squared, plus y squared equals 1, so y equals the square root of 1 minus 0.25. Let's make this even nicer. Don't just give me a decimal answer. This is the square root of 1 minus 1/4, which is the square root of 3/4, which is the square root of 3 over 2. So if I had a triangle, a right triangle, and I knew that this side was 1/2, this side and this side is 1, this side has to be root 3 over 2. Let me just stop right there, let you guys absorb. And it's just Pythagorean theorem saying that has to be true, right? Square this 1/4 plus square this 3/4 equals 1 squared. Sure enough, it does. Kick ass. These numbers, about 3 weeks from now, these numbers are going to be just coming off your tongue at the right times. These are, hopefully, these are values, part of the values that you have to memorize. This angle that represents this, that we don't know yet, that angle is a special angle. One of the many that you have to memorize their values for. So you will have to memorize values. What's really nice, if this point here is, what did we say it was? 0.5 root 3 over 2. Let's make this fractions. 1/2 root 3 over 2. You guys with me? That's what we just figured out.
Yeah.
Then if I go kind of the same, like the same angle here.
It's negative 1/2.
Yeah, exactly. Keep going. What is it?
1/2, comma, and square root.
Because in this quadrant, what happens? What's negative?
X.
X's, and the Y's are positive. And of course, it's symmetric to this dude. It's got to have the same values, except X is negative. So really, when you focus on memorizing this stuff, which you will have to do, and if you're going into calculus, if you don't know your trig function values, your top teacher's going to cry. They're going to find me and they're going to slap me. And they're going to say, that was their fault, because I told them this. And you're like, I'm just going to do this, so it'll come slap. So you have to know your values. You only have to memorize the first quadrant. Because then if I go the equal amount here, they're both going to be negative, right? So forth. You guys kind of with me? So you have 1/4 as much to memorize as it might look at first. That's kind of a nice thing. Okay, good. All right. So let me give you this. Now that we sort of talked about this, I want this visual. There's other stuff on here that you don't know yet. But I just want to give you a lot of stuff on this one sheet. Right now, you don't have to worry about the circle. The rest of it you can kind of gaze at and go, what the hell? And we'll fill that in later. Oh yeah?
Too.
Oh yeah.
She like carries it around.
So there's a ton of different versions of this. This is one of my favorites because it shows degrees and radians on it.
We have to memorize all of these?
Yep.
Yeah. Well, like I just said, how many values do you really have to memorize?
Just 1/4.
Only 4, right? Because you have the 1, 0 that we even talked about. I mean, if I just went straight out, then the x piece would be 1 and the y piece would be 0, right? So if I'm at 0 degrees, I haven't turned at all. If I'm at 0 degrees, then the point that I have to know is 1, 0. If I'm here, which is how many degrees?
0, 1.
90 degrees. It'd be 0, 1. Cool. Somebody behind you? That's you? Okay. Get you turn away. See if that's enough. Alright, so again, what did I say earlier? You don't know shit about this yet, so don't look at that yet. You can look at it, but you don't know what it is. You know these little green boxes? You definitely don't know what the hell that is yet. Right, so this is my little teaser. You don't even know how pi gets into this yet, which we'll fill in right now. We'll talk about this. This might be. Well, we got this right. So remind me, if I have a circle of radius 1, what's this guy's circumference? Yeah, what's the formula for circumference? 2 pi r. I love it. Or pi d, right? But 2 pi r is a good idea since I have r. So this guy's circumference is, what's the radius? 1. So this guy's circumference is 2 pi. I like it. So we like exact values, right? Until we have to tell somebody how long of a piece of board they got to get. I'm not going to tell them, you got to get 7.1 pi. The hell's that shit? Can you cut it exactly 7.1 pi? No, what? So how many? So that's 2 pi. That's 2 pi. How many degrees is in a circle, of course? 360. So that means, and this is, so here's the connection. Like I said earlier, that 360 could have been anything. We just weren't there to give a different opinion, right? We could have said, I don't like 360. Let's do 720. I was like, 360. We weren't there. So 2 pi is actually what's known as real, it's a real number. It's not made up. That is the circumference of the circle, period, right? Yeah. If the radius was 1 meter, this would be 2 pi meters. You'd have to walk 2 pi meters to get the hell around that. That's not made up. That is real. We can measure it. So radians are true measures. True, real numbers. That's where radians come from. And they're actually measures of angles, so I have to be a little careful. This is basically where they come from. So if I go this far, how far have I gone on the edge? How many radians have I gone? Well, let's work it out. If I go halfway, how many radians have I gone? No. All the way around is how many radians? 2 pi. So if I go halfway, I've gone pi. Cool. If I go here, I've gone pi over 2. Kick ass. So pi over 2 is how many degrees? 94. Yeah, pi over 2 radians is 90 degrees. Pi radians is 180 degrees. So forth. So when you look at your little unit circle, pi over 6 radians. Can you see that? Pi over 6 radians?
Yeah.
It relates to how many degrees?
30.
And why does it make sense? Because pi is 180. So pi over 6 is 180 degrees divided by 6 is 30. All right, let me just stop right there. You guys see that connection?
Yeah.
That is a very simple conversion between the two, and it comes from just simple facts. Right? If the radius is 1, it takes 2 pi to get all the way around, so it only takes pi to get here. So radians are actually better than degrees in one way. They are real measurements. You would have to walk that far to get here. 180 degrees, we know what it means, but it has no connection to any real anything. It's just our own made up, turn 180 degrees. It could have been anything we wanted it to be. Or maybe. If you look at your calculator, do you have your graphing calculator with you? Hit the mode button that's right next to the second button. You see something immediately important?
Radian and degree.
So, just to give you a little personal anecdote from my own life that I'm not proud of, but oh well. I did an entire test in the wrong units on my calculator. And normally you could kind of catch that, because normally it'd have like a negative answer where it's obviously supposed to be positive. But this teacher actually designed it on purpose so that it would come out with answers that would make sense anyway. And I'm like, you are such an evil asshole. So he gave me a 0, even though I did all the work right. It still sticks in my craw. So my point to that is every single math person you ever run into at some point in their life has made that mistake. So you have to be careful about which units to have it in. Obviously, if I give you radians, pi over 3 radians, you want it in radians. If I say, what's this of 75 degrees, you want it in degrees. Unless you convert it, then you always can keep it in radians if you convert it. So let me give you a couple of conversion questions right now. We know that pi radians and 180 degrees are the same thing. So if I said I had 75 degrees, how many radians would that be? How do you convert this? Let's steal something from chemistry. Don't worry, we're not going to steal moles. Well, I want moles. Right? We're going to steal conversion, yeah. So if I want degrees to cancel, I don't want degrees anymore. I want to go to radians. Where would I put them? Up here or down there? Down, so they'll cancel. So 180 degrees is pi radians. So degrees goes away. So now you just got to do 75 divided by 180. What's that? What does that reduce to? Okay, 5/12. So it's 5 pi over 12 radians. See it?
Why 5?
Well, what's 75 divided by 180? There you go. All right.
Pi 12.
Yes. It's crazy. Want to do it one more time? All right. You guys kind of with me? And where would 75 degrees be on the picture here?
In the first quadrant.
In the first quadrant. So it's how far away from this?
Closer to that.
How far away from it?
112 pi.
Good. 1/12 pi or 15 degrees away from 90 degrees, right? So this answer makes sense. It's almost pi over 2. And if this was 6 pi, this would be pi over 2, right?
Yeah.
So this is a little bit less than pi over 2.
Oh, okay.
Because pi over 2 would be a full 90 degrees. And this is only 75 degrees, poor little dude. How we doing? So I know I'm not throwing a lot at you, but it's all new. So it feels like a lot. Right? For most of us, it's all new. Yes, sir.
So every 15 degrees is 1/12 pi.
Hey, look at that. Kick ass. I love it. So every 30 degrees is 1/6 pi unit, right? 1/6 pi radians. So how about the other one? So what if I said I have, what you guys have? 2.14 rad. How many degrees would that be? And normally when you go to degrees, you go ahead and just give me the decimal. Radians, I try to have a pi show up in it, so I know what fraction of pi it is. Right? Because then we can do stuff like you just did. But there's no reason to have pi show up in degrees. They don't go together. How would I convert this back to degrees? What do I put on the bottom? Radians. And on the top, 1 degrees. Well, how many of what is which?
180.
180 degrees, pi rad. So the radians cancels. What's 2.14 times 180 divided by pi?
390. A lot.
What's it?
122.6.
That sounds better. Yeah, 2.14 times 180 divided by pi, right? So you hit your pi button, divide by your pi button, and you get 120.6
2.6.
degrees, right? Okay. Approximately. Yes, sir.
Do it again, please.
Okay.
What do we do? Multiply the 2.14 by the 180
Yeah, the beautiful thing about
and then divide by pi?
when I ask you to convert feet to inches or inches to feet, the real important question is, am I going to divide by 12 or multiply by 12? Because we know it's 12 that connects them, right? The nice thing with that method, that grid little method, is you put the units where they have to go and then you put the number in. So the first step is completely absence of thought, really. You just want that unit to die. So if I have 1.89 degrees and I want to convert that to radians, degrees would go where? On the bottom, because they have to cancel. So rad would come up on top, and so I'll end in rad, right? What goes down here then? 180 degrees,
And then just pi.
pi rad.
Do we always use the 180? Or is there...
Yeah, if I was converting between feet and inches, what number would I always use? 12, because 12 is the connection. So between radians and degrees, I've decided to use this one. It makes the most sense to me. You could use 2 pi as the same thing as 360 degrees, but that reduces to pi as 180, right? So pi radians equals 180 is makes the most sense to use as a connection. So if I start in degrees, I'm going to divide by 180 degrees, multiply by pi rad. So really, what's this divided by this? I don't think it's going to come out as a nice fraction. Too bad for us.
It was a big
21
fraction.
over 2,000.
Second,
21 over 2,000.
kick ass. 21 over 2,000 pi. But you didn't do the pi there too, did you?
No.
Oh, good, okay. So it's a fractional amount of pi. All right, let me just stop right there. You guys get a feel for, this is the real basics. This is just playing around with the units we're going to use to measure things. But we often know how to convert between one and the other because they're both used all the damn time. Okay, maybe. Good. Yeah.
We always want to leave pi by itself. We don't want to multiply pi into that. Is that
Well, you could.
that just makes ugly.
No.
Yeah. Especially if that's just not anything worth anything, you might as well just multiply pi in. But very often you do try to keep this as a fractional part of pi. Or at least show this step and then show the decimal step, so you have both of them there. Does that make sense? A lot of what you do in mathematics, there's a lot of things you do where that pi is going to cancel later. If you plug it into a formula, there's a pi in the formula, so it's going to cancel. So that's why we kind of try to write it as a fractional part of pi. That's one reason. Okay.
And then the only reason that we divided by pi in the second one is because...
It started in radians.
Okay.
So I had to put the radians on the bottom and the degrees on the top. So just to show you a simpler example of this. If I have 37 inches, how many feet is that? Where would I put inches?
On the bottom.
On the bottom.
12 inches.
So where's the 12 go?
On the bottom.
With its unit. So that's really all we're doing. As long as you know that number that connects what you want to go to and where you are now, you just have to figure out which side to put it on. And if you do this unit analysis, always make the units you're in disappear, it'll always end up in the right place. So here I'd multiply by 1, divide by 12. If it was up here, I'd multiply by 12. Divide by 1. Yeah.
But you get that fraction on the calculator, you're not doing it.
Yeah, that was
Oh.
up top. It's,
Gotcha. Let me show you this.
So new fraction.
yeah, I know.
Good, because you got that.
Yeah, well, it's still not working.
For us, we can do it in one look here. And we go all the way down. Answers, and you can put it in fractions.
All right, let me show you. I'll show you two things. I'll show you that.
Fractions approximate.
GIF. Huh? This is still 5-1, yeah.
Okay.
5-1 is chock-a-block 40 stuff. Not really, but it seems like a lot.
You have to do it again. You have to do the actual equation again.
So I'll show you two things. I'll show you how to make your calculator tell you fractional versions of decimals. And I'll show you that GIF I was talking about earlier. So what was that last thing? It was 1.89
This funky ass number. Not fraction.
divided by 180. There's a really cool little button. If you go to math, the very first one says 2 fraction. Kick ass, right? Well, I don't want my math 88 students knowing about that magic. Right. That's why I don't want anyone to use a graphic calculator. But oh well, that's good for us. Kick ass. You guys kind of see that? You with me? That's kind of nice. Now let me real quick look up the neat animation I want to show you. I say real quick, don't import anything, just open. Firefox, come on, dude. Right. It's too much. I want to have the fan blowing. I can't handle the speed at which this is moving. Come on. Oh, I actually can't. Do I have connection?
Should use Chrome.
Chrome is better.
Well, you know, if there's no internet connection here, then it's not anybody's fault. Okay, here we go.
Now it's Firefox.
Alright, let's see.
With Chrome, the address bar, you can see the one.
Alright, now watch. It's going to start right away. Alright, so there's your radius. Can you see it?
Yeah.
That's how you make a circle. Neat. Now watch. This is the cool part. It's just me. I know it. Hold on. Take the radius and you just curve it, and that would be 1 radian of movement. That's really cool. Now you see why we call it a radian, because it is the radius.
So they just searched it on Google
Huh?
when they were figuring this stuff out.
Yeah, exactly. Way back in the 1700s, they just searched Google. This was there. It makes everything easy. We don't know who put this here. It was the gods.
Mind God.
Different civilizations have different explanations. Anyway, so to me, that's cool. Now, you don't understand how hard it is to get that down in the days before simple animations like this. I mean, that's just as silly. I love to pick the radius up, curve it, and that's the radian. So that's the measure, that's actually a measure of the angle. That's 1 radian big. Cool. How many degrees would 1 radian be?
90? No.
It's not 90, right? It's right here. So let's see.
75.
Let's do it. 1 rad.
Divided by 5.
Yeah, so I want to get rid of rad, and I want to go to degrees.
So 180.
So whatever 180 divided by pi is. Cool. All right, there you go. So that kind of makes sense. It's a little more than a quarter. A quarter would be 45 degrees. It's a little bit more than that. All right. Good. Let me see, what was the last thing I wanted to say? Oh.
What were we just doing?
Right here. So 180 divided by pi. That's where they got the 57. Something odd. Okay. So last thing here, and actually a really important thing. Don't. Let's see if you guys don't say anything. If you see what this is. So if I'm here, that's like pi over 6 maybe. Pi over 6. And I want you to get to the point where if I say pi over 6 radians, you automatically know it's 30 degrees. It's like, you're not there yet, obviously, but you're going to get there because you're going to use the hell out of this thing. You're going to look at that and it's going to say 30 degrees. Sort of like if you knew a foreign language and you looked at that word in foreign language, you knew what it said. Me, I'd have to go crap and the Google Translate, right? Which they did, back 500 years ago. So if I'm at, let's say I'm here. Well, let's not do exactly that, Jeff. Let's do this. Let's say I'm at 2 pi over 3. Now, I really want you to understand why we do this. Remember earlier that if I was at pi over 3, I could figure out exactly what that point was, right? And the whole point of trigonometry is identifying how long the sides of this triangle are. So you can almost see this, well, I don't want to scare you guys. Physics is a really good place where you see trig used a lot, because if I have somebody pulling on something at this angle, I can break down that force into this force and that force. So if I had somebody pushing this way and somebody else pushing that way on something, it's going to go diagonally, isn't it?
Yeah.
And if those forces are this big and that big, it's going to go exactly at this angle. So physics likes to use trig, because what trig does is it breaks a triangle. It breaks this down into its x and y parts. Is one of the most basic things it does. It does a hell of a lot more than that. That's where we're starting. So if I am at 2 pi over 3, I would know what that point was, because I've memorized the one in the first quadrant, if I knew what this angle was. And this is the angle, we call this the reference angle. I really want you guys, we did this earlier and everybody got it then. So if I'm here and I know what this point is, if I'm at an equal angle on the other side, I know what that point is, I just have to make the x part negative. So this idea of reference angle is stupid huge. If you know what the reference angle is, and you've memorized all these angles, you can figure out whatever that new thing is. What would the reference angle be here for 2 pi over 3? Give it to me in radians. Yeah. How far away from a full pi is that? 2/3 pi is how far away from a full pi? 1/3 pi away, right? So if I was at 5 pi over 6. How far away? What's the reference angle there? Pi over 6, so 30 degrees. I like it, right? It's 1/6 of a pi away from a full pi. You guys see how to look at that to figure out the reference angle. If I was at, now here's where things get interesting. I always want my reference angle in relation to what? In relation to what? So I didn't do it in relation to this. I did it in relation to the x-axis. Because that's where everything's built. It starts here and it goes and it moves up, and I know all these. So if I know how far away from the x-axis I am in whatever quadrant I'm in, I know the values. I just have to make the right thing negative. So if I was at, let's see, look at your chart. Tell me what pi over 4. And why does it make sense what it is?
45.
45 degrees. What's the point?
Rad 2 over 2, rad 2 over 2.
Good. Root 2 over 2 over 2 over 2. And why does it make sense it would be the same at 45 degrees? Why would, and again, what does this mean? This means the x piece is just as long as the y piece is. Because it's halfway. It's perfectly symmetric, right? Yeah. So when you start here, you're all what? You're all x. And then eventually you work your way to be all y. So in the middle, you're going to be exactly even between the two of them, right? Okay. So if I was here, right, what angle would this be if it had a reference angle of pi over 4? So that's the reference angle. It's in relation to the x-axis. Yeah, because
for the plot point, or
what would this is a reference angle. So what would the actual angle be? That whole angle, what would it be in radians? Well, yeah, where'd you get that from? Because this is 2 pi. Exactly, right? So 2 pi minus pi over 4 will tell you exactly how big this guy is. So it's really how far away from a full 2 pi am I if I'm pi over 4, 1/4 of a pi away from 2 pi. I must be at 7 pi over 4. Because that's 1/4 away from 8 pi over 4. Same ideas over here, I've just got to relate it to 2 pi now, because now I've got to work with this side of the x-axis. We're going to work on that a lot more. Because the last thing I want to talk about, and I'm going to let us out early, is What was it? It was one thing. Try to remember.
So if it's anything past pi, you just go automatically to 2 pi?
Exactly. Anything past here, you go to 2 pi. So back here, you're relating it to pi. Over here, relating it to 2 pi.
Only for the last quarter?
Only for the last quarter. Exactly. It's always got to be in relation to the x-axis. So if I'm here, I'm closer to the x-axis this way. So that's going to be my reference angle. Is going to be that. So it's got to be in relation to the x-axis, the closest you can get to the x-axis. Because that would relate it to what it would be in the first quadrant. And these I'm going to have memorized. These values here. Oh, that's the last thing. That's good. All right. Here's the last thing I want to talk about. So here, I want you to notice a neat pattern. This was 1, 0 here, right?
Mm-hmm.
Okay, so let's draw this here. So this is 1, 0. Now watch this. Let me just focus on the x part. Let's just focus on the x part. And later we're going to give that a functional name. So the trig functions are defined to be those values of the sides of the triangles. So we're going to call this, eventually we're going to call this cosine. So the cosine of an angle would be the x value that it would have if I drew the triangle in. Let me say that again. The cosine of some angle would be how big the x part of the triangle is if I drew that triangle in. So cosine likes x. So cosine starts off. Let me say it one more time. Let me say it one more time. The cosine, let me put an angle here. So the angle variable that we use most of the time is called theta. Greek letter theta. That's the variable that's normally used for angles. So cosine of theta is the x part of the triangle you would get if you drew that triangle in for that angle. So here's theta. Draw the triangle in. X part is what cosine is. It's a function, but that's its definition. So it's not cosine theta equals the square root of x squared minus 2 or something. It's actually an idea. The cosine is the x part of its triangle. Neat. All right. Good. Some of you guys are like, oh yeah, this is awesome. So, now watch it. This is kind of cool. The next point up, what's the x part? So that would be for pi over 6. So the x part starts off at 1. What's it become at pi over 6?
Add 3 over 2.
So the cosine of pi over 6,
Add 3 over 2.
root 3 over 2, right? The x part of the point is root 3 over 2 there. You guys see where that's coming from? Now what is it at pi over 4?
Root 2 over
Root
2.
2 over 2. What is it at pi over 3?
1/2.
Root 1 over 2. Let me write, oh yeah, isn't that the same thing?
Yeah.
Root 1 is the same thing as 1. So you guys see where I'm going with this. And actually I can write 1 as 2 over 2, which is root 4 over 2. Why the hell would I do that? Because it goes from root 4 over 2 to root 3 over 2 to root 2 over 2 to root 1 over 2 to 0 over freaking 2, right? At 90 degrees, how big of an x part do I have?
0.
0, because it's all freaking
On the
y part. Mind blown. Maybe.
Yeah.
And real quick, has anybody ever heard of SOHCAHTOA?
Yes.
Okay. Did I tell you about my feelings about foil?
Yeah.
Alright, and you know you can still use it, but you understand what I meant, that it's not very useful, it only is useful so far? Same thing for SOHCAHTOA. I'm still going to talk about it. If you know it, you can still use it, but it's much better if right now you know that cosine is the x part, and what we call sine is the y part. Cosine likes x, sine likes y. That will get you through everything. SOHCAHTOA will get you through parts of this book. So it is useful. And if you've never heard of SOHCAHTOA and you think it's a camp you go to in the summer, I understand. They have shirts like that, Camp SOHCAHTOA. No. We'll talk about it, don't worry, it's coming. Alright, that's the last thing I want to show you, is that neat pattern up there. Hopefully I'll help you memorize these things. That's it. Anybody not get their test back? Okay.
Yeah.
Do it more time.